Hello, welcome everyone to the A4Q Testing Summit, and thank you for joining us. We are excited to have you with us for this two-day event, bringing together the global testing community to share ideas, experiences, and practical insights around software testing and quality engineering. Today, alongside our A4Q sessions, we also have
Hello, I think there is a connection problem for the AFS side. Maybe I can present. Yes, so I will start. Welcome, everybody. I can start with a question that how many tabs do you open for testing and execution in a test automation setup? ID terminal, ID itself, ID terminal, documentation, CI dashboard, all to figure out why a test failed. We are going to change that. Today's talk is about something that genuinely changed how I moved through a test suite by pairing an LLM with Pytest via the model context protocol. We will keep it concrete with real repo, real numbers, real conversation logs. So our agenda is what is MCP, how the MCP server can integrate with the Pytest, and our implementation based on the MCP server and interactions, how you can create your MCP server based on our MCP. Like we said, let's talk about MCP. Of course, we cannot deeply cover the protocol. At least we can understand what it is and how we can use it. MCP, the Model Context Protocol, is an open source spec Anthropic introduced in late 2024. The simplest framing is it's a standard way for an LLM to talk to tools and data outside itself, which means one protocol, many backends. Look at the animation. The LLM doesn't know your Pytest setup. It doesn't know your file system. It doesn't know your APIs. MCP is the bridge between tools and LLM. LLM discovers them and calls them. There is 4 primitives for the MCP itself, like there's a resources. These are data the model can read. There are tools that are the functions the model can call. Prompts are reusable templates. Sampling is controlled generation. For us, the interesting one is tools. That's how we expose Pytest. The other 3 matter for richer integrations, but you can do a lot with just tools. To keep it simple, it's always important as a software lifecycle explanations also. So you can think MCP as a USB driver, like you can plug in any tool, any LLM, and no custom glue. So how we can actually use it? There's easy 3 steps. Step 1, implementation and MCP server. The Python SDK from Anthropic gives you a server class and decorators to register your tools. Step 2, tell your AI agent where the server lives. I choose the Claude desktop also for the demonstration, but you can use the other language models to integrate with it. But for Claude desktop, that's the JSON config you see on the right, and you define your pad as a shell script, and that's it. You just show that, okay, my MCP server here to ready to run, and you can execute it. The step 3, and then you can start conversation. The model now sees your tools and decides when to call them. You don't write any SDK glue. You don't manage states. You don't parse anything. If you ever wired up a Slack bot or a webhook, this feel familiar. Expect, instead of writing event handlers, you write tools and the model figures out when to use them. Let's go through the bridging the LLM and your test suite with a Pytest. But before that, we can give what before and after situations, of course. Basically, why we combine them. How many tools are open right now while you're debugging a failing test? IDE for the code, terminal for Pytest, browser for documents, CI dashboard for history, maybe a notebook for analysis. That's a lot of context switching. At the moment, you stop doing this every day. You forgot the marker syntax. Was it -m UI or -k? Temp completion can help, but it gives you some headaches. That's most daily life every test automation engineer faced. Of course, the failures itself. There is a 30-line traceback, and the information is dense, but only if you know what to look for. Non-technical mates, they simply cannot explore tests at all. They need your guidance. They need your reports or explanations. But the afterside is what the conversational interface gets you. Plain English in, explanations out. The test framework hasn't changed. Pytest still is a Pytest. You can drop the integration tomorrow and lose nothing. The important part is, like I said, Pytest stay as Pytest. No fork, no plugin lock-in. If MCP disappears tomorrow, your tests still run. So here's the full flow. Let's check the animation. A developer asked Claude in plain English, run the UI tests. Claude maps that to an MCP tool call run tests with markers equal UI. So the MCP server translate that into the actual Pytest command, pytest-m UI-v with a JSON report. Pytest runs, results come back as JSON. The server formats them. It can be passed, failed, skipped, durations, tracebacks. Claude reads the result and answers in plain English. Five passed, all green. I'm using Claude a lot because this is the example that I have in my hands. So there is 3 notable things during this flow. 1, there are 0 custom integrations. Anthropic's SDK does the protocol work. 2, latency is dominated by Pytest itself. MCP adds about 15 milliseconds. 3, It's stateful between turns. So show me the failure pickups when you left off. Let's go through our code itself and explain it, the structure, the project structure, and the example that how we execute it. So our repo is small on purpose. The point is to show what actually requires, nothing more. We have calculator app, we have tests for calculator, we have server itself, and we have sh file that can activate your environment and necessary things. So calculator app file, a real desktop calculator built with Tkinter, real UI, real math, real error paths, not a countrywide example. Like I said, the test calculator file has 15 Pytest tests organized with the markers, UI, error handling, and slow. And we have about 96% of coverage in this little project. Server, of course, the MCP server itself, that's the whole bridge between the LLM and tool itself. Like I said, the run server is that activates the virtual environment and launches via SDO transport, which is what Claude Desktop expects. If you fork this repo today, the calculator and the tests are the most you will throw away, of course, but the server file is a part you will adapt to your project. So here we have three options in our MCP server: run test, list test, and get test results. And run tests is the workhorse, takes a path, optional markers, capture mode, etc. It adds the JSON report with flag so we can get structured output. 5 minutes timeout and graceful failure. List tests discovers without execution, run Pytest collect only flag, and useful when Claude is asked, for example, what's in the project. No need to execute everything, just to count. Get test results. Read the last run from disk. Let's Claude reference yesterday's failure without rerunning the suite. This is a bit that makes the conversation feel stateful. Could you add more? Sure. You can generate tests, run coverage, compare runs. I keep it simple because these three tools are enough to demonstrate the value without complicating the abstractions. So notice that each tool returns formatted Markdown because the LLM is excellent at reading Markdown. If you give it structure, and it gives you better answers. So now we can watch the real integration. I will show you with the real Claude Desktop demonstration, but also with this, I want to cover most of the cases. So now the animation plays the whole turn end to end. So left side, the chat, I type run the error handling tests. No markers, no flags, just intent. Right side, the execution panel, Claude decides on its own to call run tests with markers error handling. The MCP server runs Pytest. 3 tests come back passed with durations. Claude reads the result and replies in a natural language. 3 tests passed, 0.06 seconds. Your guards work as expected. Total elapsed time from my enter key and useful answer under 3 seconds, including the test execution. More importantly, I never had to switch out the chat. The next question, what about edge cases, happens at the same turn and will with full content preserved. You can continue your tests based on the content, and you don't have to switch different areas, different tabs, different terminals, I would say. So also what we measured based on this, we measured the average time reduction across the 5 tasks is over 45%. The biggest win was failure analysis. It's more than 58%, because the LLM explains the trace back for you also. So on the comment side, for example, in the queries, 56 less that our native language query replaces about 3 calls. So 1 query, 3 CLI calls, which reduces a lot at the time. People stop typing Pytest flags to remember also. So also reliability itself, 99.2 across 100 sessions, 1 timeout, no crashes, MCP overhead stays under 1%, even 1,000 test suites. So the most benefit one probably is the average task time reduction, which is over 45%. And I don't have to remember the marker syntax anymore. So before closing my presentation, I would like to show you the real demo in the Claude desktop to demonstrate how it can be powerful for anybody. So without saying anything, I already implemented my MCP server this desktop. If I say list tests, let's see, Claude can understand and run my test test. Of course, I need to allow it. It's always asking this kind of questions. It knows where it goes. It says what the number is, and it gives much more information to you also. But if I say just run tests, then also it goes to the MCP server, understand the test context, and it start to run and give you the option that, okay, what's passed? But I want to see what's the results more deeply. So if I want to get the results, it will also ask again, and it gives you much more detail. You can go through, talk with it, explain with it. It's already there and ready for you. That's the server itself. Maybe a little more explanation. Someone wants to use it. I want to give a little more explanation based on the code. Just mention that we are using only the tool side of this MCP. So with the tool object, you define your tools, you give the description, and you give the input schema. That's the thing that how the Claude or language model can understand what it should do. Then we define the functions, which we have 3 of them, and the rest goes through with it. So here maybe you can see, okay, in the console, which flag that you can choose, what will be the executable, you defining everything in there. So basically, what you type as a text, MCP server understand that, okay, the text content has run test, list test, get test, or similar to that with the description. Then it knows that which function that it can run, and it goes that function, that function is just create the command it should run in the terminal itself. That's how I can explain and demonstrate to you the basics. So for my side, thank you for your listening, and is there any questions? I'm glad to answer.
Thank you very much, Mehmet, for this insightful session and for showing us how AI and testing are becoming more closely connected through technologies like MCP. Before we continue, I'd like to apologize for the small interruption in the beginning and any inconvenience caused by the network connection issues. I couldn't control that.
It
now,
happens.
now I'd love to open the floor for audience for the question. If you have any question for Mehmet, please feel free to put them in the chat and we go through them. Okay, is it still worse using MCP or is it better to use CLI commands, which could save us a lot of tokens and context? Isn't this a better approach, especially for building frameworks to avoid costs?
Yeah, of course, but related with the tokens and the context. For example, I'm not like a seller. I don't want to be shown as a seller of the Anthropic or Claude desktop, but using MCP gives you much power to how you can say if there is a problem with the LLMs or the connection between your engines. If you get rid of it, yeah, you save. But if you create the CLI commands, which save a lot of time and better approaches, this is related with the LLM directly. MCP is just a plugin, and it just gives you opportunity to use your tools with the machines or language models that you have. The related with the costs, you can create your own engine that run on your own local area, and you can do whatever you want with it. It's depends on the budget, of course, but that's I can explain it in this manner, I would say.
Okay, thank you. Next question.
I think there we have still a little little problem with it, but I think I understand. Like make the with Pytest, yeah, for the test engineers writing the few tests because the LLM writes them. Yeah, LLM will write the tests, but the test engineers should evolve like how you can say as a quality experts. And there, my thing is the business side and the development side, we are the bridge as a testers. So what's the MCP does also? It's a bridge that between one thing to another. The thing is right now, for every time, I think, we just need to connect the dots. That connection gives you the opportunity to evolve yourself. Yes, we can write fewer tests. We can create less tests based on the features, but we have the responsibility more to understand the feature itself, the human behavior, or the product, the system behavior better to create these systems which usable, better understandable, and this usage, this knowledge needs some, how you can say, experiences. So we know the business side, we know the development. Right now, we have LLM, which knows both sides also, and we have better ammunition. That's how I can explain that. So, building agents and the MCP are different topics, I would say, because MCP is a protocol. It's a network layer, you can say. The other one is a behavior layer. With the agent, agent decides plans, creates different tasks, and you have much more instructions there. MCP is just a protocol that you make the connections between the tools and language models. There is no competition between the agents and the MCP. That's how I can explain.
Okay, let me jump at Tiff's place, who's having technical issues. Sorry about this. Thank you, Mehmet, for this insightful presentation. Thank you for taking the time to answer these questions. If you have more questions, please don't hesitate to reach out to Mehmet and continue to share with him. You can also vote for Mehmet as best speaker and best presentation directly on the website. Don't forget that we have sessions every hour, all day long, today and tomorrow. And you can find the whole Testing Summit program on our website. Thank you again, Mehmet. Thank you for attending the A4Q Testing Summit 2026.
Thank you.